This is question 46 of your grade 11 physics class for Doppler shift, as is obvious by the title. Now this question will prove to be a little bit different in how it runs out. It's a little bit more math intensive, I should say. You don't have values for all of your variables. You have ratios for some of them. And so just pay careful attention to the math. And in fact, there's less calculations to do with this question than there is with the other ones we've been doing so far. So it reads, how fast must a source be moving relative to a stationary observer such that the observer hears a frequency A 3 times that of the source and B 1/4 that of the source. Speed of sound 2 by 325 meters per second. Speed of sound 2 B 325 meters per second. I don't want any hate emails for my grammar, even though they're probably earned. Anyway. Okay, so now setting this up is the key. So for A, 3 times that of the source, we want to hear an observed frequency to be 3 times the source frequency. So we don't know exactly what the source frequency is, and that's all right, we don't have to. You'll see here, I don't want to ruin any surprises or anything like that, but you'll see it works out quite nicely. I've got my speed of my observer, 0. Nice and stationary, makes things a little bit easier mathematically. Speed of sound, 325 meters per second. So I have my relationship between my observed frequency and my source frequency. I'm trying to figure out how fast the source actually must be moving. So there's my question mark. How fast must this object moving for this relationship to happen? The observed frequency to be 3 times my source frequency. Well, let's start by writing down the formula, and we'll plug things in. Observed frequency equals the source frequency times speed of sound. And I'm just going to leave that blank for a second. Speed of the observer. And on the bottom, speed of sound and the speed of the source. And the question always remains whether I put a plus on the top or a minus on the top. Do I add those two variables together in the numerator or subtract them? Just think about what's happening in part A here. So just a quick reminder that this is part A. In order to hear a higher frequency than the actual source, you have to be going towards each other. That makes the formula positive on the numerator and subtraction in the denominator. Now here's where a little bit of the math comes in. The observed frequency is 3 times the source. So instead of F observed, I'm going to write 3 F SRC equals F SRC. Put my numbers in for speed of sound. And then the bottom, 325 minus how fast the source is moving. And that's the whole point of the question. Now, it looks like there's 2 unknown variables. But if you look carefully, we can divide the frequency of the source out. We have the relationship between the observed frequency and the source frequency. So because we have that relationship, what the actual frequency is divides itself out. Okay? It's essentially dividing both sides by frequency of the source. So I'm left with 3 equals 325 over 325 minus speed of the source. The equation really looks, I think, mathematically simpler now than some of the other problems we did. And so cross multiply. Now remember, those are still together. When we come up and cross multiply this, very common mistake is to only multiply the 325 by 3, but both terms have to be multiplied by the 3. So 325 times 3, 975, minus 3 times the speed of the source has to equal 325. So on the right-hand side, subtract the 975 from both sides. So 325 minus the 975. So this will be negative 3, speed of the source equals negative 650. With this relationship, all velocities should work out to be positive. Their directions are taken into account with the actual formula by using the plus or minus in the right spot. Divide both sides by the negative 3. So that'd be 650 divided by the -3, 217 meters per second. So in order to hear a frequency 3 times higher than the source, on the day where the speed of sound is 325, this object has to go 217 meters per second. So you're basically in a plane, a very fast plane. All right. Now quickly we'll do B. I don't want this to go on too long, but it's good to see how the math works. B says is 1/4 that of the source. So rather than writing down all my variables down again, I'm just going to write down that my frequency observed equals 1/4, or my frequency of my source over 4. Okay. So now we'll go to the formula. Frequency observed equals frequency of the source times the speed of sound. And leave that blank. Speed of the observer over speed of sound. And leave that sign blank. Velocity of the source. But we're going to be solving for the source frequency again. Go up and double check my question. How fast must it be moving? Yep. So it's 1/4 the frequency observed. Now, if 1/4 is less than the actual source frequency, which means they're now receding or moving apart from each other, so the numerator has a subtraction in it, the denominator has the plus. Very easy mistake to make. Now my observed frequency is my frequency of the source over 4. I make that little substitution. And then my right-hand side has my 325 minus 0 over my 325 plus speed of my source. Same as last time, we've got a frequency of the source on both sides. They can be divided out. So be very careful here. When you divide that out, you're not left with a 0 on the left-hand side of that numerator. You're left with a 1. Frequency of the source divided by frequency of the source is 1, just like 5 divided by 5 is 1. So you have 1/4 equals 325 over 325 plus speed of the source. Good old-fashioned grade 9 cross multiplying. 325 plus the speed of the source equals 4 times 3 1/4. 325. So 325 plus the speed of the source equals, quick calculation, make sure my math is right, 1300. Subtract the 325 from each side. So 1300 minus 325 equals 975 meters per second. Wow. Really fast. Now, I know that works out to be about 3 times the speed of sound, so this probably just isn't something you're going to regularly see. But you'd have to be moving extremely fast to have a kind of 1/4 reduction in frequency as it passes you by.